We now look at the sum of two Poisson processes. So we say the superposition of Poisson processes. Suppose we have two Poisson processes and they are independent with arrival rates, say R1 and R2, lambda 1, lambda 2 or. Then if you add them up, the meaning is that by time t, if you count both arrivals from these processes, then it's again a Poisson process. Of course, the rate is the sum of their individual rates, right? R1 plus R2. Okay, and let's use an example to illustrate this sum of two Poisson process problem. Okay, so here we have an example. Now we know it is not true that all the time emails arrive according to Poisson process, but this is just an assumption. So assume that I have two email addresses with emails merged into one inbox. So two processes, they're going to put together. And when they arrive, assume that the numbers of email arrivals for both addresses form two independent Poisson processes with rates R1 is 8 and per day and R2 is 2 per day respectively. Okay. So now let's look at the following four problems. Okay. Number one, if we count the email arrivals in inbox, what is the rate of this Poisson process, this merged inbox? So according to our guideline, that the answer to number one is simply the sum. So we have, let me call this new Poisson process LT, and that's going to be NT plus MT. And then its rate, let me call it R, and that's going to be R1 plus R2, and that's going to be 8 plus 2, and that's going to be 10. It's easy to understand, and then that's 10 emails per day when they merge together. Okay. Second, then let's look at what is the probability that by the end of the day, I mean first day, there are exactly 10 emails in inbox. You remember 10 per day, but what is the probability that we have exactly 10? So that's the probability over here. We are calculating that end of the day, so t is equal to 1. L1 is exactly equal to 10, and that's what we have. Now, according to the formula, let's try to recover the formula over here. The probability of a Poisson process is equal to k is equal to lambda t, and that's actually the mean of nt to the power k and e to the negative lambda t and over k factorial. And we know that the expected value of nt is going to be simply lambda t, and lambda is the arrival rate. So if we use that formula, then this is what we have. We have lambda t, in this case, t is 1, lambda is 10, so we have 10. So we have 10 to the power 10, that's a big number, and then multiplied by e to the negative 10, that's a small number, and then divided by 10 factorial, which is again a bigger number. Usually this is sufficient if we don't want to really find an approximate value, but if you want to, you can actually use a calculator to find it, and this is approximately 0.125. So you can see it's 12.5%, or just say 0.125. It's good. So you can see the probability is pretty big, but it's not as big as we would probably imagine. And that's what we have. Okay. So now let's look at the third one over here. If we find exactly 10 emails in inbox by the end of the first day, what is the probability that 3 emails are for address 1 and 7 emails for address 2? Now, let's go back to look at it. So what we are talking about for address 1, and that's the rate we have 8. And for address 2, the rate is 2. So if we have exactly 10 emails, usually we would expect 8 emails for address 1 and 2 emails for address 2. So the probability to get 3 emails for address 1 and 7 emails for address 2 is pretty small. But how can we find this probability? Remember, this is conditional. We have the condition that exactly 10 emails arrived by the end of the day. So if we look at this formulation over here, we are trying to find the probability that NT is equal to 3 and MT is equal to 7, but you have to given the condition that NT plus MT is equal to 10, and that's what we have. Now, we have to use the conditional probability formula. So this is going to be the probability that NT is equal to 3 and MT is equal to 7 and NT plus MT is equal to 10. That's A intersects B, right? And divide by the probability that NT plus MT is equal to 10. Now, we already calculated the denominator in item 2, so we can actually write it down. But on the other hand, if we look at the intersection over here, if NT is 3, MT is 7, then NT plus MT is automatically 10. So really, if you look at this event over here, this is the same thing as the probability that NT is equal to 3 and MT is equal to 7. You can just throw away the last one because it's the same event. And then you have the probability that NT plus MT is equal to 10. Okay? And then what we need to do is to now use the independence. So by independence, NT and MT, they are independent. So we have the probability that NT is equal to 3 and the probability of MT is equal to 7, and divided by the probability we have NT plus MT is equal to 10. Okay, and that's what we have. Now let's use the formula again. So remember, for NT the mean is 8, so lambda is 8, and T is over here 1. So we really just look at T is equal to 1 over here. So the first one, we have 8 cubed and then e to the negative 8 and over 3 factorial. And that is the probability of NT is equal to 3. And then multiplied by second one, the rate is 2 now. 2, but now k is 7. So we have 2 to the power 7. And then multiplied by e to the negative 2. And over here is 7 factorial. And that's the numerator. And denominator, we already have it. And that's going to be 10 to the power 10. And times e to the negative 10 and over 10 factorial. Okay. Try to simplify this. We see the following thing, that e to the negative 8 times e to the negative 2 is exactly e to the negative 10. So we can cancel these terms over here. This one and this one and this one, they are cancelled. And then what we have over here is the following. So we have the answer, and we have 3 factorial and times 7 factorial and 10 to the time 10, and that's in the denominator. And in the numerator, we have 8 cubed and times 2 to the 7th and times, and we have 10 factorial. I'll leave to you to find out an approximate value for this conditional probability. So approximately equal to what? And now let's look at the last problem over here. So what is the expected number of emails in inbox by the end of 7 days? So now what we are looking at, what is the expected value of the number of emails from both accounts and by the end of 7 days. So we put 7 over here, and that's what we have. And of course, we know it's lambda times t, right? Lambda is gonna be equal to 10 and t is 7, so that's gonna be 70. Of course, we know on average we have 10 emails a day, and after 7 days the average is gonna be 70.